Live, what is up, everyone, and welcome to the Data on Kubernetes Community's live stream number 127. We're piling it up. We got a live stream today with WeaveWorks. We got a live stream tomorrow with DigitalOcean. Got plenty of things going on as usual in the Data on Kubernetes community, but our biggest piece of news is that we've got our third virtual DoK day coming up on May 16th in Valencia. We'll be live streaming all of the talks. We got over 30 talks and panels that we got coming for all you folks on May 16th. I will be down there in Valencia. We're going to be doing everything virtually. All right. We will be having a get together afterwards. If you're interested in attending, please contact me on Slack so we can get you on the guest list. Can have live music, entertainment. It's going to be really, really cool. That being said, like I said, we've got plenty of meetups coming up. We've got a meetup tomorrow. If you're in London, you definitely want to check out our DoK London page. For more info, you can see all that on Meetup. We have a special meetup group just for our meetups in London. So that'll be happening tomorrow. A hands-on lab with Kasten, taking a look at the importance of backup and restore when we're looking at databases on Kubernetes, followed by a panel with three amazing people: Jennifer Riggins, Anais from Aqua Security, and Cheryl Hung, who's an advisor at ONDAT, one of our sponsors. Shout out to ONDAT for all their support in London. She's also at Apple. So that's our second in-person meetup that we're having in London. Get ready for more of those coming up soon. We got one planned for Turkey in May. We're definitely gonna have another one in London in June. We got one coming in the Bay Area in July. So anyway, plenty of news going on there. That being said, our speaker today is Scott Rigby, and he's an amazing human being working at WeaveWorks, a super cool company if you're not aware of them. So Scott, I'd like you to turn your camera on so we can get to see you. How you doing?
Hey, I'm doing good. Hi, everybody. I'm recovering from a little laryngitis, but it's fine. I might be slightly less talkative than normal, but yeah, still here and able to do this. Thanks.
Very nice to have you with us, Scott. And something that we ask the different guests that we have here in the community is, when people talk about running stateful workloads on Kubernetes, we talk about the challenges and opportunities. Could you just give us a little bit of insight about what your experience has been with that, your perspective and your feelings about it?
Absolutely, yeah. So this was a big topic. It's been a big topic for years, and so this talk is on Flux for Helm users, right? And specifically with a specific focus on stateful workloads. Pardon me. So I had maintained co-maintained rather the Helm incubator and stable, the incubation and stable Helm repos for 4 years, and this was one of the main things that I want to bring to that when joining the team to do that was helping with consistency across those very popular community charts that were maintained by a bunch of folks very intimately familiar with the applications each were supposed to manage, right? And a number of those applications are stateful. So one of the things that we did first of all was try to understand and develop best practices for Helm charts when running stateful workloads. We still have a bit of documentation there that has yet to make its way into the Helm docs. That's on my list. It's just not the very top priority right now. Maybe it should be, I don't know. But I sent a link. Essentially what we did was poll all the Helm chart maintainers and ask them about their ideas for best practices. So it wasn't just about stateful workloads. That's just one of the sections, and a very long list of best practices that should be highlighted for that repo. Now that repo is long since decommissioned. Its charts have moved to other distributed Helm repositories. They're all aggregated on the CNCF Artifact Hub. So Helm users hopefully know this. If they don't, now you do. That's where you can find thousands and thousands of charts. But those best practices are still they're still important. And I'll actually pull up the link now, if that's a good.
Absolutely, yeah, great segue. Go for it, yeah.
Okay, cool. I actually didn't prepare to do that, but that question inspired me to do so. So, 1 sec here.
All right.
I believe it's in the there we go. If it's in the review guidelines, here we are.
Okay.
Shall I send that to everyone in the chat?
Yeah, just send that here. Yeah, perfect.
Okay, cool, great.
Good.
And so there's a section called deployments, stateful sets, daemon sets, selectors, and that is the best practices for that generally. That's under names and labels. There's best practices around the actual selectors themselves, and then below the selectors, below the selectors section, there's persistence labels. So there's a section specifically for stateful sets. And then if you go down to the very bottom, there's Kubernetes native workloads. So there's just a few recommendations. This is probably not that that groundbreaking or exciting at this point, but basically what we had said was that workloads that are stateful in nature, such as databases, key value stores, message queues, in-memory caches, are to be created as stateful sets. So it's recommended that deployments and stateful sets can config their workload with a PDB for high availability, the pod disruption budget. And those are really the only notes that we have. Really, most of it had to do with selectors and labels. And those. So what we tried to do was be consistent with migrating Helm charts that will only offer deployments to also give a stateful set option in their configuration, because some charts only offer a stateful set, and fine, but it's very nice, I think, to give the option in a chart, because if you're using a chart for development, you don't really need to worry about the stateful side of it so much, unless that's what you're specifically developing for, trying to work with. You know what I mean? Yeah. So, but in all other cases, either with charts often have a file that has a production-values YAML file inside the chart itself, so that you can also pass that to your commands for Helm installation, whether you're using a tool like Flux for GitOps and you just pass that in your Helm release configuration, or if you're using the Helm binary and you use the -f command for values.
Very good. Nice overview. And it's nice to see, we see the development evolution of Kubernetes over time. And so part of what's fascinating about our community, talking to different people, is how everyone has their own, story of how they first got involved with this. And like you said, even if some of that documentation is now in a different place or is in a different phase, identifying when and where these things are happening, why they're happening, and the impact of that, it's really cool. It's kind of like a historical kind of piecing these things together and seeing how we got to where we are today. That being said, if you want to start sharing your screen, jump into your presentation, go for it.
Sure. Okay.
And folks, as usual, if you have questions, please feel free to put them in the chat here on YouTube, and we will get them answered accordingly.
All right. Give me just a sec here.
Okay.
I'm glad I could still join you even with my voice being as it is. Just let me know if you need me to repeat anything.
Will do. Yep.
Okay. Okay. Can you see that?
Yep, looks great.
All right, awesome. So So hi everyone. We started off with a little like a short intro question with Bart, and just to let you know kind of who I am and why I'm speaking on this topic, or like, I guess you're here, so you're interested. I don't need to sell myself, but just so you know, I work at WeaveWorks on the developer experience team. Um, pardon me. I'm involved in various CNCF things, including I co-chair the CNCF GitOps working group. I co-maintain the several CNCF projects, including Helm, Flux, and an open GitOps. And so yeah, this talk is basically the focus is on using Flux to implement GitOps for Helm users. So my Twitter handle's right there, R6BY, the old leet thing. And feel free to reach out to me about open source projects there or on CNCF Slack anytime. Okay, so in short, this is just what I'm going to cover as quickly as possible. Here's a quick agenda for you so you can follow along. I'm going to just go over who the talk is for, specifically audience that it focuses on, so you can kind of gauge where to focus in this for yourselves. Going to give a brief context for new users, just so we're not using terms that, if there are even one or two or a handful of people that are brand new to this, you won't get lost. You'll at least know what we're talking about, and you can use that context to follow up, later as well. I'll go over the benefits of Flux for Helm users, and then I'm going to show, or I'm going to discuss tell you briefly about moving from the Helm CLI to the Helm controller, because the majority of Helm users do use the CLI, really the Helm client. When you type in Helm create or Helm install, etc., or they use that in CI. And then I'm just gonna demo that if we still have time and if my voice doesn't just give out before. Okay, so basically, yes, certainly this is for existing Helm users. You may be using, like I was just saying, Helm CLI by hand or in CI automation. Just getting started with Helm. However long you've been using it, whether you're a seasoned veteran, or you just downloaded Helm today, you should be able to follow along with this talk, and it really is for you. So I'm looking forward to following up on your questions as they come up. I believe Brett's gonna speak them to me at points, and we can just do that.
Absolutely, we'll do it.
Okay.
Yeah.
Okay. So actually, here's a question. I probably should have asked this before I even started, but are there any new users to Helm on this call? Is it a known group of people who all use Helm already and have done it for a long time, or?
Let's take a look. We do have a bit of a delay, but we can all get some feedback in the chat.
Yeah. Well, I'll be brief about this. If you already knew, I could just skip it, but I think it's good to give it a tiny refresher. I won't spend a lot of time on it, so it won't bore folks, even if everybody's super seasoned. I'm just not going to assume any specific knowledge about GitOps or Flux. But yeah, if you do get overwhelming directional requests for this talk, let me know. But I'm flexible.
All right.
But I'll start with a short intro to all of those. So just to be welcome. Okay. So what is Helm? It is a widely adopted package manager for finding, sharing, and deploying apps on Kubernetes, right? In the context of Helm, you're going to hear terms like charts, releases, revisions. So similar to apt or yum for Linux, Helm manages packages for Kubernetes called charts. Charts contain a set of related Kubernetes resource definitions for applications, which can be deployed to a cluster along with your user specified configs for how that application is supposed to behave in Kubernetes, right? Or just how it's supposed to behave when you deploy it. The deployed Kubernetes objects And the user-defined configuration values together is what we call releases. So if a Helm introduces this concept to Kubernetes of a release that's not native to Kubernetes, you probably know that, but releases that are managed by Helm have revisions that users can use to roll back to if needed. And that's the value of that, and that's what those mean. So Helm charts exist for most applications that can be run on Kubernetes. I mentioned CNCF Artifact Hub. There are nearly 7,000 charts to choose from last time I checked. And there are tools to help you, or some labels to help you find official charts and other things like that. So you don't have to be overwhelmed by paradox of choice, but you can find most of what you need for most applications. So in order to guide you through the benefits that Flux brings to Helm, I'm going to briefly note some things that are in and out of scope for Helm by design, before we move on to what is GitOps and what is Flux. So Helm is a client and SDK only. That was part of the design when moving to Helm 3 a number of years ago. So Helm provides an SDK for other tools to make best use of its internal functionality, as opposed to only having to use the CLI or shelling out to the CLI, which might be a security concern in certain contexts. But I'm not saying using the Helm CLI is a security concern in itself. It's not. It's a client, and most of the time it's used by human operators, and it's often used in CI. And it's sometimes or CD. So, those are options. But here are some of the things that are designed to be out of scope because of Helm's because of Helm's tighter scope now on the client and the SDK that powers it and other tools. So you can see generally that what's in scope. Again, I'm focusing on the scope that relates to GitOps, by the way. So there are, but this is still accurate for scope for Helm. So yes, supports the CLI and SDK. Since I'm going to be talking about Flux next, Flux uses Helm's SDK. Note that not all tools do that, and that's perfectly okay. Just know this when you're comparing tools. In fact, we just published a Helm blog post for Helm. Excuse me, give me 1 second.
No worries.
This is probably worth showing you because it just came out yesterday. Yeah, that myself and Matt Farina wrote, advice from other people and contributions from other folks too, which was nice. I'll post it in the, can you see this? Can you see it on my screen? The tools you can use to manage your Helm releases declaratively.
Got it. And I just shared the link in the chat. So yeah, we're all good.
Okay, cool. I don't know if I had only shared a tab or.
No, it's cool. Got it. Yep.
Okay, great. And at the bottom here, you can see that one of the columns you can read through this later, but this is a comparison of tools that to help you manage Helm declaratively, which is going to be part of my talk here. The column that says does not require Helm binary, those are tools that use the Helm SDK. So that just gives you an idea there. I'll go back to the slides here. Okay, so in any case, so the rest of Helm scope is packaging those Kubernetes manifests, configuration for those manifests. So there is Helm templating. It uses Go template, which some people with YAML. We actually considered removing that in Helm 3, but due to vastly overwhelming community, not really, I mean, almost demands, but cries really pleading, we decided to leave that because it's important for Helm chart maintainers and for Helm users that have those options that it affords. So that's how we do the configuration. It's got imperative app delivery. So ultimately, in scope for Helm is imperative commands and versioning and rollbacks and what I spoke about before. What's out of scope that mirrors the other side of this. The corollary here is that CRD upgrades are out of scope for Helm because it is focused around the needs of the Helm client, and a client is not an ongoing operator. You can try to make that happen, but that's not what the Helm client does. That's out of scope. So Helm does not manage. And there's plenty of posts and documentation on why Helm does not manage the lifecycle of CRDs, including upgrades. Spoiler: Flux Helm Controller does that, and I'll show you when we get to there. But also, what's out of scope is managing multiple environments. You got to use other tools for this, and if you're a Helm user and you're working on automation, you probably are either using. If you've been doing it for a while, you're probably using something like Helm file, or some combination of bash and a makefile. I myself have done this a lot. I'm going to try to be a little more terse in my descriptions now. Any control loop or retry logic, and you can read these other scopes. So basically, like any kind of automated responses apart from rollbacks, and there's no drift detection whatsoever in the scope of Helm. There's a tool, there's a Helm diff tool, but there's nothing like that in the scope of Helm. So please check out these GitOps principles. I'm just going to read them briefly. But it's just important for folks to know that GitOps is a set of principles for operating and managing software systems. This is what we say in the actual principles document. Which is at open-gitops/documents as the GitHub repo. So the principles are derived from modern software operations, but they're also rooted in pre-existing and widely adopted best practices. So the desired of a GitOps managed system must be these four things. It must be declarative. It must be versioned and immutable. It must be pulled automatically. And it must be continually reconciled. So note that none of these descriptions or the linked glossary items from here are Kubernetes specific. These are supposed to be foundational principles. Oops, can you hear me okay?
Yep, you sound great.
Okay, my internet gave me a warning, but
no, you're all good. Sounds great.
Okay. So a very quick note about what we mean by declarative. Principle one is really it's the difference between declarative and imperative. So with it's that Kubernetes users know and is likely know anyway, and is documented in the section of the Kubernetes documentation on the three different ways of working with Kubernetes objects. So declarative is the most highly recommended way, but imperative is supported as well. So with declarative management, just in a nutshell, you declare to the system what you want the end state to be like. The system then works to make that a reality, and it usually reports status on the progress of making that declared status a reality. Over time, the way a system makes the declared state a reality can change without the need for you to declare or the status of the progress to change. Imperative management has to do with telling the system what to do step by step. Instead of declaring what you want in the end, you tell the system each step to achieve that goal, and you monitor that as you go, and you're responsible for each of those steps. You're also responsible for what happens if there's any change to that, like a kind of drift between your desired state and the actual state of your system. So principle one is very similar to infrastructure as code, except that it applies to apps as well as infrastructure. Principle two is where the name GitOps comes from. Although any system that fits the criteria defined by this principle may be used. And the principle states that desired state is stored in a way that enforces immutability, versioning and retains a complete version history. So GitOps gives you, Git gives you that out of the box if configured correctly. But other systems do as well. Other systems can as well. And they can be used together too. For example, S3 compatible storage buckets, Helm repositories, and at least as far as Flux is concerned, very soon OCI. That is in process right now. So principle 3 is what differentiates GitOps from event-driven CI jobs triggered by changes to Git, the pulled automatically part. So here the desired state is pulled by the system whenever needed, without the need to be triggered by actions on the source repository. So, CI, you make a change, it triggers a job. If that job succeeds, you've done your thing and it doesn't happen again until you make another change or manually re-trigger that job or go and investigate why that failed yourself. Whereas GitOps, that should be happening from the system on a regular basis itself. You can speed that up with Flux, and I believe other systems too, other GitOps systems, but you can speed that up with a webhook receiver in Flux, so that when you make a change in CI, in addition to the regular interval of checking that it will do all on its own, it will send a ping to the source controller and say, all right, now go ahead and pull that source again. But it won't send that entire payload. It won't push it in the same way. It really is just giving you a little push, a nudge to say, hey, let's speed this up so it can still, so this pull only system can compete with the same level of speed that a push-based system would, just with greater security. And principle 4 is that this is where software agents are always assessing the actual system state, working to bring it closer to declared desired state in version control. So hope that was helpful and not boring to everyone. If you're already an expert in GitOps, if every single one of you is, then maybe that was, but at least you know where to go to point other folks to this information. You got a few extra side notes. Okay, so what is Flux? It's a CNCF incubating project. So it is in the process of, it has applied for graduation and is in the process of review by the CNCF TOC. It's in a very good position. We just had a meeting about it yesterday with the TOC. So the Flux family of projects are a set of continuous and progressive delivery solutions from Git to Kubernetes or whatever that source is for. So this includes the Flux CLI, the GitOps toolkit, which is a set of controllers and Go packages that power the Flux CLI and can power other tools, and Flagger, which is a progressive delivery tool built to work with GitOps. That has moved under the Flux project space. That was voted on last year by Flux maintainers in a public issue. So remember those things I said Helm doesn't do by design? I gave the one teaser, but Flux basically picks up where that scope leaves off, at least in the context of GitOps. So Helm is the packaging and release tool. Flux allows for collaborative, declarative, and automated management of complex environments. Flux is the only CD tool that purely uses Helm's SDK. No shelling out to a binary, and does not also fork Helm to do that. Now, I will say that for a long time, Flux was the only CD tool. There may be others now. I just don't know if some of the items on that list that I showed you before, that table, like I don't believe that Fleet is a CD tool. Captain may be considered a CD tool. So in any case, just take a look at that blog post we just published for current, up-to-date, as of yesterday, details on that with footnotes. Make sure to read the footnote. I wrote a lot of those, and we worked on those together as a team, and they're important caveats and things that users need to know when assessing and comparing these tools. They're all good tools. They all do different things, and it's just good to know the facts. So anyway, because Flux uses the SDK, it allows Flux to do very flexible and powerful things while maintaining a very solid architecture and a low memory footprint in your cluster. As a side note, folks who are interested in a low memory footprint for their own cost, but also environmentally sustainable purposes, there is a CNCF environmental sustainability working group that is being proposed. And I will point you to the charter right now for those who are interested and want to list yourself as an interested party. Only do so, of course, if you are interested, but I am personally extremely interested in this and already working on it. Yes, so one of the other benefits of Flux is that you can save a lot of memory as opposed to running certain things within shelling out to the Helm binary in a container. We can get into that more if you're interested, just asking the questions. So, okay, well, anyway, because we're SDK users, it also means that Flux team and Flux maintainers contribute to the Helm upstream so that everybody gets the benefits of improvements that we make along those areas, not only Flux users, open source, right? So, but that's one of the other benefits of using the SDK for us. So another big benefit is Flux Helm Controller manages CRD upgrades. So Helm CLI has support for initial installation of CRDs, as many of you probably know, required for the resources in your cluster, but it does not handle upgrades by design. So normally this is a manual step for charts that install apps, which upgrade their CRDs every so often. A common example of this is Cert Manager. You'll see instructions on how to do that manually using Cert for Cert Manager upgrades. And a number of other tools. And the Helm controller allows you to do this out of the box. And it has options to let you fine tune CRD upgrades with automated, anyway, it has options to allow you to fine tune the automated CRD upgrade process as you need to. But for many people, you generally don't even need to tweak those. It just works out of the box. What I had mentioned earlier about the memory footprint, Flux has a depends on feature, which allows you to manage a tree of chart dependencies without having to make large umbrella charts in order to do that, which I know many organizations currently use. It's a very viable solution. We have documentation in the Helm docs on how to use umbrella charts and various chart dependency models, or several chart dependency models. But because the Helm controller is, the Helm controller is a software agent running on your cluster with a very low memory footprint, but running there nonetheless for unattended operations. We introduced a depends on feature so that you can just specify that in the custom resource for your Helm release, so that you can let the controller manage that tree, create that tree of dependencies at runtime, and operate on them one after the other, as opposed to having to load it all in memory in order to do so all at once. So that's very helpful for that. Flux also makes it easy to manage multiple events. We've got a bunch of documentation and demos and showing you how to do this. Flux is built on controller-runtime, on Kubernetes core controller-runtime. So that includes control loop and retry logic out of the box. Basically, we integrate with it, but if you're using Kubernetes and you hopefully already trust this, Flux gives feedback on how automating your Helm releases is going through the notification controller. That includes automatic drift detection, which is when resources in the cluster diverge from your desired state all on their own. For some reason, something fails, a bad actor got in there, a good actor accidentally pushed the wrong environment, and so on. So I'm not going to read all of this. I have plenty of things to say about Flux and on the homepage of fluxcd.io. Just know that Flux does multi-cluster, multi-tenancy, multi-cluster out of the box with cluster API, that is. Other GitOps tools that boast the same thing do the exact same thing. And Cappy is a fantastic project. We integrate very tightly with it. Cappy is also written on controller-runtime. Excuse me. So for example, Flux can use one Kubernetes cluster to manage apps in either that same cluster or multiple other clusters. So you can have very lightweight clusters that don't even need anything Flux related running on them. So this is really good for things like edge computing, and it's being used by telco, and it can be used for you to save money, and if that's part of your desired architecture. Anyway, there's a lot to say about these, but I'm going to try to save my voice and get on with the demo, or get on with the talk. So this is just a short overview of the Flux controllers. That is ultimately what the GitOps toolkit is, and what Flux is a set of APIs and controllers. These controllers are source controller. Let me just describe them very briefly what they do. Source controller watches your defined sources where you specify your desired state. So for example, Git, and brings any changes into the cluster for that of any of your specified changes for the other controllers to then act on. So that's why it's first in this list. The customized controller gets your change, or excuse me, let me just say real quick, the desired state in Git can be a variety of popular formats. It's plain YAML. For those who don't want to use plain YAML because they want to be more dry, it supports customized overlays and Helm charts to do that. It also supports, there's also now a Terraform controller that lets you store your desired state in that format. So ultimately, you can, and there are more tools coming. There is a project that Stefan Proden has been working on for Q, if you prefer that form. So, so in any case, regardless of the format, that's what the source controller does. Watches for your changes, brings that information of your changes into the cluster, at like the GitOps principle said. So the customized controller, the next one on the list, is the controller that gets your changes from the source controller and applies plain YAML as well as optional customized overlays to the cluster. Those YAML files include Kubernetes resources, any Kubernetes resources, but also include the custom resource definitions that other Flux controllers, such as the Helm controller, rely on to do their job. One word on the naming here. This has confused some people because they're like, I don't want to use customize. I'm a Helm user. You can use both, but also you don't have to. The reason the customized controller is used to apply plain YAML, including the Helm release CRDs, is because in architecting Flux version 2, the current version of Flux, to support customize is built into the Helm CLI. Or excuse me, sorry. Oh my God, that is not true. Customize, don't snippet that out, please. Customize is built into Flux, into kube control. Let me say it one more time. Customize is built into kube controller, kubectl, however you like to say it. And so customize also wraps kube control apply. So in providing customized support for applying customized overlays and other advanced customized features, it also just hands that off to essentially the underlying tooling for kube control apply to apply just plain YAML too. So that's why we don't need a plain YAML applier and a customized applier. I hope that clears it up for the few people who might be confused about why we have customized for Helm users.
I think we're good. Yeah.
Okay. So once the Helm repo and release CRDs are applied to the kube API by Customize, or like say, however you decide to get them there if you don't want to use GitOps for that or something custom. The Helm controller uses that information to automate managing your Helm releases for you. The notification controller then, I think I already mentioned that, but just lets you know how things are going, any drift, etc. And then the image automation controllers handle writing exact image versions back to your Git source in your desired, if your desired state is a SymVer range or constraint like Helm supports. So a lot of your Helm charts, Helm supports like, here's a SymVer range, right? This is basically version pinning for GitOps. And the reason is because it's now an automated process and it applies to scaling as well as disaster recovery. If you specify a SymVer range that it's anything within this minor version, any patch release within a particular minor version, or who knows, any minor release within a particular major version, or any other SymVer constraint you want to that's supported by Helm. That means that if you use GitOps to spin up a new cluster and manage multiple clusters, that next cluster wouldn't know exactly which version the other clusters had already chosen, which you know what I mean? So basic concept of pinning that allows to write back that one definition by a machine by this controller, not to compete in any, it doesn't compete in any way with your user specified configurations. It's very separate using annotations within the configuration file. But that just allows that. So there's more to be said about that, but you can, that's for another talk. I just wanted to mention that, like, about a quick note about the Helm controller is that, like, you know, experienced in Helm myself, as it sounds like many of you are, I wanted to contribute to Flux too, because I was very interested in GitOps. And after researching, I found Flux's Helm controller to be the most stable and the most powerful GitOps tool for the wider Helm ecosystem. Again, when I put my GitOps working group hat on, chair hat on, you know, we don't prefer one tool over the other. We just give facts about them. I think I've done some of that, and I'm gonna move on now. But I just want to take a quick look at an architecture diagram to shows you how these controllers work together to manage Helm releases using GitOps, using GitOps. Short description is like, you can see on the right, or actually, I don't know if you can see my mouse, but on the right are the sources here that the source controller is pointing to, and it's pulling from. The source controller is also giving that information to the Kube API. The Helm controller, as well as other controllers like the notification controller, the custom controller does too, but it's not part of this this diagram here because we're talking about Helm releases only. The Helm controller talks to the source controller, listens to information from the source controller, and so does the notification controller, which feeds that information back to you through Slack or through dozens of other team chat options. And then the Helm controller controls the Helm releases themselves and the release lifecycle for Helm, just like you expect with the CLI. Oops. Okay, yes, so show me the benefits, right? Okay, so already got some of the length. I'm not going to get into additional benefits. It's just like a very quick, to put it on a bumper sticker is like, you know, Flux gives an additional layer of reliability, consistency, observability, auditability to the benefits that Helm already provides you when using it in CI, when you're just using the Helm client. So when moving from the Helm CLI to the Helm controller, it all starts with using with Helm declaratively. You have to be able to do that before you can do GitOps, however someone wants to do it. There is a blog post that that Tamao Nakahara published on CNCF blog here.
Cool.
That shows how Flux lets you use Helm declaratively, and it's a pretty in-depth focus on that. The blog post that we just put out in the Helm blog is more of a comparison, so it doesn't get quite as in-depth of exactly how Flux does it. It just gives some important features to note in comparison to other tools. So look at those two resources, and that'll really help you with the declarative part. And really, I want to highlight that users trust Flux. Flux was one of the only two projects alongside Helm categorized as adopt on the CNCF CI/CD Tech Radar that was published in 2020. So if you follow the CNCF Tech Radars, they come on different. Each Tech Radar is on a different topic. That one was on CI/CD. Check it out. And if you do need additional help, beyond seeing or get on these demos and things like that, I'm just going to send you a link to Flux support. There's a little section that says my employer needs additional help, and there's different companies, including the one that I work for, who are listed as folks you can reach out to for different kinds of engagements, from the very light to like extraordinarily involved. All of them, I'm not differentiating one to the next. Even though I work for WeaveWorks, they're fantastic, and so are the other companies listed. And if you offer Flux services, paid services to help other folks, open up a pull request to list it there, because Flux is an independent CNCF project. So really just the one note here, I'm not going to really get too into it, but just you're all here because you know change is necessary. You want to see how to do CI/CD with Helm and Flux, and you're a Helm user. So, but everyone else who you need to convince to make that decision might not be on the exact same page there, knowing how necessary it is. So we can help with, you can reach out to me apart from this. You can point folks to this demo, this talk, or this demo, and other recorded versions of it that I have, and other people that are talking about this. We give tips how to convince whoever you need to, basically. Ultimately, excuse me, about when I say users trust Flux, large companies, small companies, old and new companies, highly security-minded companies like financial institutions and government, as well as extremely open projects, all use Flux. So, and there are success stories that you can point to, different quotes and talks and so on. So just, they can share with you, and that you can share it with them, and taking ownership is a lot easier that way. So yeah, I am now going to do a time check, but I want to go to demo, but I want to do a time check on where we're at.
We are ready for the demo. We're good.
Okay,
Let's do it. Let's do it.
How much time do we have left for it, if you don't mind?
Oh no, how much time do you need? Don't worry.
Okay.
Yeah.
Okay. Yep. I thought I might, my voice might have cut out, so I'd be a little shorter with the rest, but I was able to persist. So here we are. Okay, so let me go ahead and stop sharing my screen now, and what I'll open is a gist here. I'll open this with CLI on the side. So give me just a sec to stop sharing my browser so I can share my entire screen so you can see both at once. Just a minute. Okay. Okay, here we go. Sharing entire screen now. We're sharing entire desktop now, rather.
Yep, we got it all.
Okay, got my do not disturb on. Okay, cool. So here's the gist. Let me post it to you in the chat, so it might be easier for some folks to follow along that way. In short, what we're going to do is show you going through. Let me just cue this up for a second, and then I'll explain what I'm doing. So, because this will only take maybe 30 seconds, and then bootstrapping Flux will take about almost a minute. So I'll just copy paste it for now, and then I'll explain to you what I'm doing as I'm going through these. So this is focusing on homebrew users, but you can go to fluxcd.io to find a variety of ways to install Flux. This just will help you. I don't know that this is actually the most recent version now, but it's not too far behind if it's not. So there are a few things that you need to do. One is to generate a new token in your dev settings. I'm going to now that the creation of my local kind cluster is done, but you can do yourself. I'm going to do a Flux Bootstrap, and I'll explain to you on it too. Give me just a second here. I'm deliberately going to my 1Password. It won't display anything to you that you shouldn't be able to see.
So no shopping spree with Scott's credit card.
Yeah, exactly. This is good. I need to create a token because now GitHub has these expired. I didn't check that beforehand. So why don't I stop the share, create the token, because now that would give a shopping spree for all the repos I maintain. So that's no good. And then I'll just restart my share, but I'll show you. I'll give you the link to how that's done. I'll talk you through it. Basically, what it is you go to your GitHub account. You go down to settings. You click all the way down on the left to developer settings. You click down personal access tokens. And if you have an expired one, I do, you click delete. Hey, actually, in fact, I'll share off and on here so you can kind of get a feel for this. And then I'll stop when it comes time to actually have it show my token. So I'm going to click generate new token. I'm going to use the name Flux Bootstrap because I like to do that. I'm set an expiration for 7 days. Thank you, GitHub, for adding that feature. And then you're going to click the repo button. So you need to give all repo controls because Flux Bootstrap will create a GitHub repo for you if you don't already have one named by whatever you specify it as. And if you do have one, it's idempotent, so it will just act upon that. And it still needs permission to do so. So I'm going to click generate token after I stop the share. All right, 1 second here. Generate token. I'm going to copy my token. I'm going to pop it into I'm going to update my 1Password, at least so I can use it over the next 7 days in demos. And I'll save that. Okay, I'll reshare with you now. Always encourage using best practices here. Another thing that I'm going to, oh, Jesus. I'm not sure if it's because I'm sick or what, but let me do that again. I'm going to stop the share and then I'm just going to remove that entirely. So I created that and flashed it on my screen for a second, and it has deleted. So So have fun trying. I'm gonna close that. Thanks for bearing with me on this, folks. I'm almost running on all cylinders here. Okay. Did the same thing, but now I just won't show you. Okay, what I will show you though is it won't take very long to kind of make up for that. Is a more is a better way to do this using instead of pasting your personal access token or just relying on like Flux's secure way of posting it. You can do this. You can do a read-s, and that's read silent. And just to make sure, let me see, no new lines. There we go, my bad. And then should be 40 characters. That's what I expect, you know, for a GitHub token, right? I actually got that properly with the read silent. You can actually do this in a demo. If you do this, you have to export it. I'm actually not going to, yeah, actually I'll do it. Well, why not? I'll export it. Okay, so now I'm going to do the Flux Bootstrap command again. Okay, so now what it's doing is it's creating a repository called Flux for Helm Users. Oh, it actually looks like maybe I had that already set up. Still a good demo. It'll still work. How about I do? How about I just go there? Oops. Flux for Helm Users. So it looks like this is 20 days old, and there's already four commits. I think it may be good to revert to the very first Flux. What's the best way for me to do this to show you? Because I actually meant to delete this. Bart, how about I could show you several things, but just so that it's kind of scripted here. I just want to explain what I could do, but I'm gonna do a thing. I'm gonna delete my kind cluster, delete my repo, and show you starting from scratch, just so you know you can do it.
Okay.
This shows that it does in fact work. I can actually do a before I delete it, I'll do it a Flux get well, here, I'll do a Flux get, or I'll just do a kube control for now before I introduce that. Get deployments. And well, let's see. There we go. I'll just do Helm LS. So this shows how I essentially have a running system. So what I just did kind of reproduced disaster recovery, because I just created a cluster and used Flux Bootstrap to take the manifest I already had in my repo, and my application, my Helm application, my Helm release is running as an actual Helm release in the cluster. I'm going to go ahead and delete it though and start from scratch. It'll only take another minute and a half. I hope that's okay. Because then you'll get to see how to do it yourself from scratch. And you'll get to see, you know what? I'm just gonna assume that this audience is very very intelligent and not do that. How about that? I'll save you an extra minute and a half, and I'll just go through the steps and show you what it looks like. And we'll take it from there. So just know that you can follow along with this link that I sent you. You can do the steps yourself. You can see that it works. For now, trust that it does, and from scratch. But it's also nice. Actually, this may be a happy accident because it'll show you how you can use an existing Git repo. You can bootstrap over an existing repo. You don't have to always do it from scratch every time. It's designed that way. So after you export your invars, you create the demo cluster. You do a bootstrap, which does essentially what I was saying, makes a repo if it didn't already exist, and it correctly generates a deploy token for your repo. It properly generates a secret with that deploy token in your repo. It does not use your personal access token anywhere else besides your CLI. It's 100% restricted to your client right here. So you don't have to worry about any kind of privilege escalation there. That's never sent to your cluster, and it's never sent anywhere or used in any way other than setting up only this. In fact, once you do the bootstrap, you don't actually need to use the Flux CLI any longer. In fact, you don't even ever have to do Flux Bootstrap. You can bootstrap manually, and there are instructions on the Flux CD website under installation on how to do that. This is just by far a very nice convenience feature for folks. So that's a word on security and reliance. You're not required to use the Flux CLI. It's just you probably want to. You can then clone your newly created Git to your local workspace. I'm actually going to go here and see if I do. Looks like I don't. So I'm going to go ahead and clone it, just as you would if you were getting started. Or let's say as a new engineer would if they were either moving to a new computer or a new engineer on a team that already has this in production, etc. So this is probably good to see as well. So I'm going to show you the tree now. I've got some extra things here because I had already done this, and I'll just explain to you what I had done. So what I did initially, this is nice to see, is what I did to start how to create these custom resource definitions for Flux, which is here. This is what they look like. In order to do this very easily, or to simulate how you would do this easily for a complex chart with many values, I am using a very simple chart that does have valuations. This pod info chart that you see us using in a lot of demos. So I wanted to set some values to make it fun. So I set a UI column, I looked at the values using Helm show values. I created a Helm release just using the CLI. You don't actually need to do that, but this is just simulating how you would move from an existing Helm release that you install with the CLI to Flux and GitOps. I installed it using Helm upgrade, and I used the set command, or you could do this with a file, but the same thing. I used the set command to set some of these values. So I made a replica count 2. You can see that here, log level of the bug, and the UI color. Okay, here I have a blue. So then you use the command flux create source. It's very similar to the help command, except this is not imperative. When you export that to a file, this file here. So it's really just, you have to create this, the source, just like you would do with a Helm add repo or Helm repo add command. This creates a source so that the repo information can be grabbed and continue to be updated unattended by you. So that looks like this. It's really just a custom resource defined by the Flux source controller for Helm repository source type. You can also install Helm charts using just a path in Git or an S3 storage bucket. And again, soon with an OCI path. So then we created the Helm release, and this is how we created this file. First I did Helm get values, spit it out to YAML, which looks like this. You all have probably done this and do this on your own if you're a Helm user and automate it at all with CI or otherwise. And then I use the Flux create command for the Helm release type, this file itself, to make it. So you just pass the parameters very similar to the Helm upgrade install command. You have to specify a chart version though, because again, this can be a Semver range, but you have to specify some kind of version, either a pin version or a range. This is just greater than 4.0.0. And namespace default, and pass the values file that I just exported to this command. And you can see that it passes the values as a, YAML map, actually as part of the YAML object, as part of the spec values, the values part of the spec. So then, here I'm just in this simulation, I'm catting it, and then you no longer need that Helm values file. If you push it to Git, it automatically deploys that release to Git, just like you saw when I didn't use the Helm CLI actually in this demo at all, which is sort of nice now. And that Helm release is there just by having that Helm controller look at these definitions in Git, these custom resource definitions. So yeah, so what I was going to show you is that what it does, if I do just a kube control git deploy my release, you can, well, let me not just grep, let me just do a yeah, this is it in context here. So it actually applies metadata labels for showing that Flux is in fact controlling this Helm release. Controlling this deployment object that is part of this Helm release. So that's how you know when you're going through steps on your own for the first time in a fresh installation that that push to Git actually had Flux kick in and pick up on these changes. So what I did, and as you've already seen, I just changed one of the values from red to blue, which we have right now. Let me show you actually just, that it does have a blue background. I'll actually reverse the here and change it to red and push it. So you can see that we'll make a change to the Helm release. Oops, sorry. We'll make a change to the Helm release without actually using the Helm CLI at all, and just pushing it to Git, and we'll see it automatically pick up in the cluster. So I'm going to change it, or let's change it to yellow. Horrifying, but let's do it. I'll do a git add p, so you can see that I've made that change just in my Helm release custom resource definition that Flux recognizes. I'll commit, do yellow now, and I'll do a git push. Okay, so if I do a watch Helm ls-a, that app version, that Oh, actually, sorry, it already worked. Okay, so it already moved to the second revision in this cluster, which is nice. Now I should be able to show you this exact same thing. Just port forwarding again. And there it is as yellow, right? So you can see this running in the cluster. You can see, you can use Helm, because it's a Helm release in the cluster, you can see the different release versions. You can use plugins like Helm diff to see the diff. Really, it's ultimately going to be just what I showed you and all of that. So, so that's kind of a reverse of what I had shown in the from scratch demo, but it's really the same thing. So, so great. I want to now show you back to the here. I'm going to show you what happened, how you can pause and resume, or in Flux language, suspend and resume releases on a Helm release basis. So let's say what I just showed you is very simple, right? But see how this helps a lot when you have, I don't know, let's say dozens or a handful or dozens or hundreds or more of Helm releases, sometimes with very complex value structures. So, so let's say you want to do this, right? And you need to do maintenance on the Helm release. Well, you don't have to pause all of your GitOps in order to do that. You can pause just one single resource. In this case, like a Helm release. So I'm going to pause that. I'm going to send that. And you can see, I'll use the flux git command. A flux git Helm release, my release, all. And or you could do the namespace, right? And you'll see that it's suspended is true. So I can now roll back my release to, I think we had 2 revisions, so I could roll back my release to revision 1. This is simulating incident management, right? So you're essentially suspending GitOps for this one release in your repo. If you were using a customization to package these charts or Terraform or something like that, you could do the same thing, just on a per delivery controller object basis. In this case, it's a Flux release, or excuse me, a Helm release. So I'm going to do a Helm rollback to revision 1. And then, I'll port forward again. All right, and then you should be able to see that it's back to blue. I should be able to now do, I fix my, you're a platform team or you're on an on-call team, and you've done your incident management, you've suspended GitOps. And by the way, we do have a note about when it's appropriate to suspend GitOps within the GitOps working group, GitOps principles. It's in the glossary under, I think it's a note on breaking glass or incident management. But now if I resume that Helm release, I could show you that suspended equals true, but let me first port forward again and show that it's gone back to yellow because it's taking the configurations that you now have in Git again. Because when I manually did this, I was creating drift between your defined desired state in Git, in your source, and your actual system state. Now that we've picked back up on GitOps, it's pulling that again and pulling away any manual changes that may have been made in the cluster accidentally or on purpose, either by a good actor or a bad actor, right? Or an actual good reason or not. So that's that. Yeah, and you can see, let me just go ahead and show you that suspended is false now. This is good if you have a whole list of every Helm release here will show up in a big list, so you can see which are suspended and which are not. That'll help you with not only incident management, but also auditing to see who's doing what and what the audit trail was. When GitOps was suspended and it got kicked back to manual intervention. You can also set policies to disallow that, but on certain environments and so on. So, let's see. So for fun, I'm going to clean up my demo, or just to show basically wrapping up the demo, right? I'm going to do a kind delete cluster. Hope you like my little Barney reference here. So our cluster's gone, but our Git source is still there. So let's just simulate disaster recovery right now. I'm going to create, I'll do a kind Git clusters. There's none, right? I'm going to create another one. I'll only take, oops, I'm sorry. Kind create cluster. So I'm going to simulate disaster recovery here, or I just did by deleting the entire cluster. Let's just say something horrible happened and your production cluster went down, or all of your clusters went down. Okay, maybe that cloud provider, you need to, maybe you're switching to your backup cloud provider, or maybe it was something known and you can just spin up new clusters, or maybe who knows what, right? You didn't pay your bill. No. So we now made a new cluster, and now all I have to do is use the Flux Bootstrap command again, because it bootstraps, I'll use the exact same Bootstrap command. It bootstraps Flux components into your cluster, and you can't really have Flux from within your cluster without those components. So that's what Bootstrap means, and that's what it's for. So once that's actually there and able to read your source, again, that you already have kept, like my source is still here. I deleted the cluster, but my source is here, right? All my commits that you already saw are here. So now Flux is bootstrapped. I should be able to forward again and see my release is running. So we've got, here, I'll stop port forwarding, and I'll just do a helm ls-all, and I'll show how, and this shows how there's a brand new Helm release on this cluster, which is why it says revision run again, because revisions are cluster specific, right? Just like that's part of core Helm. And you've now simulated disaster recovery. Imagine if there were hundreds of these Helm releases, lots of manifests with plain YAML managed by customize, various policies about your cluster and so on. In fact, imagine if your management cluster defined all of your other clusters that it manages, and all using cluster API, right? And you've got, let's say, an entire fleet of clusters and hundreds of clusters or whatever, or even just dev stage prod 1, prod 2, prod 3. This works exactly the same way. This is one simple example to show you how that disaster recovery allows you to depend on these battle-tested controllers built on Kubernetes controller runtime, and can get you up and running extremely fast. So so I've got a little list of things that we covered. I don't necessarily need to go over them now, but just review them if you want. And I hope that helps show you some of the magic of GitOps, especially for Helm users using Flux. I think you're muted, Bart.
Anyway, that was very, very good, Scott. Very well explained. Great to have the resources to accompany the explanations as well. So we got all the links in there. I imagine some people are going to be contacting you either on the DoK Slack or the CNCF Slack, because this is something that we see gaining traction. 3 weeks ago when I was in London, they were talking about using policy as code and GitOps when talking about stateful application storage. There's really, you can't say it's hype. It's just something that's adding value, and people are really picking up on that. I do want to share. Sorry, no, go ahead. Yeah.
Well, I I can find the link for you, but to that point, Pinky and I just had done a talk on ways of structuring your Git repositories, and we focused not on Helm. We focused just on plain YAMLs, but noted how we're doing that just for introductory purposes, and you can replace that information with your Helm releases like I just showed you here. But that includes policies, setting up clusters, and all of that stuff. So check out that talk too. It's recorded, and yeah.
Good. All right. Just before we wrap up, thanks everybody for attending today. Like I said, we have this awesome meetup today. We got another one tomorrow, KubeCon, DoK Day, all these things that are coming up. As is tradition in our community, I'm going to share my screen really quickly, make sure I'm getting the right one. While you were talking, Scott, we have an amazing artist in our community. His name is Angel, and he does graphic recordings of all the talks that we have. So he did I think you can see my screen now. Let me know when you can.
Whoa, that is so cool.
Good. And the thing is, while we were talking, earlier when I was checking out your profile, I was like, Scott's also got a background in the arts world, and we could definitely talk about that more later. Probably need to have just a whole live stream dedicated to that because you really know both the artistic side as well as community building, and that's a huge, part of what we do here. So this is sort of a compilation of the things that were being shared and discussed. But just thank you so much for giving us your time today. It was really nice to learn from you. And you're very easy to find on Twitter, LinkedIn, like I said, CNCF Slack as well as ours. So if folks want to continue the conversation, you know where to do so. Anything else you wanna add before we finish?
Just thanks for inviting me, Bart. And I'm really happy to learn more about your program. And I'm looking forward. Are you going to be in Valencia?
We'll definitely be there. Yep.
All right. So I will see you there, and all of the rest of you, whoever is able to come. And thank you again.
Looking forward to it. Shout out to Vanessa from WeaveWorks as well too for making the connection here, as well as all the other folks in WeaveWorks, Leonardo, Jose. Anyway, lots of great people there. Great group of folks you got going on there. So anyway, Scott, enjoy the rest of your day. Hope you start feeling better soon, and thank you for sharing your time with us.